right, let's actually start building our automation engine. So the first thing we're going to do is open up the Intel XDK IoT Edition and select blank template to begin with. I'm going to name this automation. And the project has been created. I'm going to delete the comments here and then begin with creating our application. So the first thing that we want to do is import all of our libraries. Here we're importing an Mqtt library, which allows us to access, the Mqtt broker. We can both publish and subscribe to data with this package. Mongoose, which is our MongoDB database library that allows us to read and write from the database. We have an HTTP library that will allow us to send RESTful HTTP requests. Lodash, which is a utility library for dealing with manipulating arrays and objects in JavaScript. And then we'll load in our own custom configuration file. This will contain all the parameters such as the IP address and port number for the MQTT server and the MongoDB server. All right, the next thing that we need to do is import our schemas. So these schemas are defined in a package called Intel Commercial Edge Network Database Models. This package simply contains a couple of models that have to do with the workshop and these webinars that go through and teach people how to build their own IoT edge networks. Next, we're going to import the utilities library, which is just a library that we're going to write that has a couple of helper functions, and announce to the console that we are starting the trigger daemon. And we might call this the automation daemon, whatever you want to call it. It basically runs business rules. Okay, next, the context object. Now, we talked about this a little bit inside our presentation. The context object contains JavaScript objects that we want to be able to pass into the predicate function and into the action function and make available in those functions. So the first thing that it contains is a list of all the automation rules. Second thing that it contains is the stash. The stash is an array which holds the last value from each sensor currently on the edge network. So if the temperature sensor is sending out data, the stash, if you access it with a particular ID of whatever the temperature sensor's ID is, will return the last data point that that sensor sent. After that, you can import as many libraries as you would like. Here in this case, we're importing the HTTP library and the MQTT library. And this is so that if our automated rule needs to send an HTTP request or an MQTT needs to subscribe to MQTT or send an MQTT message, it'll have the library available to it to do those things. You might put in other libraries here. If you wanted to use SMS, you might use an SMS library, or if you wanted to make a database query inside your trigger, you could do that as well by passing in Mongoose. All right, next. Next, we're going to initialize our connection to the database. So here we have the Mongoose library. We're connecting to a URI that we will define inside our configuration file. Here, we're saying to the DB, if there's an error event, then bind the error reports to the current console. So in this particular case, we're just going to be logging our errors to the console. And if there's an open event, if the connection is created successfully, then log that to the console as well. All right, here is our first function that allows us to trigger or to receive all of our triggers or all of our automation rules from the database. So this function uses the trigger model, and it finds all of our automation rules and then executes this function on those triggers. For each of those, we just print a line to the console that says retrieved this particular rule, retrieve this particular rule. This is very useful when you're running and debugging, just to make sure that when you launch your automation server, all the rules are read in. So we define this function here, and then we call it. And that's the first thing that our automation service will do, is get a list of the current set of rules. Okay, next. We're going to connect to our MQTT server. So in our configuration file that has our all of our IP addresses and other URIs, we're going to get the MQTT broker URI and assign an MQTT object to this variable called MQTT client. After that, we're going to send a function to be run every time the connect event happens. When our MQTT client connects to the MQTT broker, we'd like to print a message just saying that we've connected to an MQTT broker. And then we're going to subscribe to two different channels here. One of them triggers refresh. We won't really use here. I set this up simply to be a way that I could send a signal to this server to ask it to reread all of the triggers from the database. So you can send a message to this queue. This server will reread the functions from the database. Another way you can do that is simply to restart it. It depends on how you want to make it. For simplicity here, I'm not going to implement the function that goes through and downloads all the triggers from the database. We're just going to concentrate on our sensor data here. So we're subscribing to sensors, and then this plus is a wildcard. So in place of where the sensor ID is, we're putting a wildcard. And then we're subscribing to the data channel of all of those sensors. So in effect, this subscribes us to the data channels of all sensors on our local edge network. All right, next. Next, when we receive an MQTT message, we're going to call this function. We're going to call a function that first of all just logs it to the screen, and then we're going to parse it. Now, if you remember back to our second webinar, the webinar where we used visual programming tools in order to send data, we set up a format that looked like this. Let me show it to you again. This is the format of the data that's coming over our MQTT topic. Now, one thing to note here is that even though this is in JSON format, it's going to come into our program as a string. So we need to take this string here that has a sensor ID, a value, and a timestamp, and we need to parse it. So we take the message, we parse it, convert it into JSON, and if it's properly formatted, we'll come back down here to an if statement, which detects whether this particular incoming MQTT message was sent over the sensor topic. And we'll implement this function in a little bit and put it inside our utilities file, which we haven't even created yet. So if this is sensor data, then let's send it to a function called process sensor data. All right. Next, let's create a couple of helper functions for us. This filter triggers by sensor ID. What this does, and we're using Lodash here, as you can see, is that we're taking the list of all triggers and we're filtering it by whatever this ID is. So say, for instance, we have 10 sensors on the network and we want to single out the temperature sensor. What we can do here is say that the list of triggers has triggers that apply to all 10 different sensors, but we're only interested in the triggers that relate to our temperature sensor. So this function here will help us filter our list of triggers, and it will return a list of business rules or triggers that relate only to whichever ID we pass in here. In our case, in just a moment, it'll be the temperature sensors. This is a very similar type filter. The difference between it is that this one returns only the triggers that are active. So by using both of these together, we can get a list of all business rules that relate to a temperature sensor, a particular temperature sensor, that are currently active. All right. This is our main process sensor data function. It's a larger function. The first thing that we're doing is we are getting the JSON that we passed in right here. And we are getting the sensor ID out, so which sensor that it came from, and the current value of that sensor. So you can see over here, those are, for this particular case, we're using temperature as the ID for the temperature sensor, and we're getting different values here. Okay. Next, we're going to use Lodash and say for each, and this for each function takes two parameters. The first one is a list of items to operate on, and the second one is a function. And what this does is this is an iterator. It'll go through each each item in this list in order and call this function. So we're filtering all active triggers, and we're filtering for all sensor IDs that match the sensor ID of the JSON object that we passed in, which in our case here is temperature. Once that's done, we have the rule that we're operating with. We're going to come down here and call the rules evaluate condition. This just calls the predicate function of this rule, and it passes in our context object and our JSON structure. And you can see that it'll either evaluate true or false. If it's true, we're going to evaluate the trigger function. If it's false, then we do nothing. And then at the very end here, we have the stash. And I put this in just so we can keep track of not only the most recent value, but the two most recent values. And they'll be called sensor ID, in this case temperature, and temperature underscore previous. Okay, next let's define our utilities function. Here it is, and let's paste it in. Okay, here are all the different utility functions that we could use. I remember earlier we used the isSensorTopic. That simply takes a string and matches it to sensors, some ID, and a data channel. Okay, and let's also define our configuration file. Okay. Here are our two configuration parameters, the MQTT brokers URI and the MongoDB URI and database name. Okay, we're just about ready to upload this package to our gateway. Actually, there's one last thing that we need to do. We need to come over here to the package.json and tell it what our package dependencies are. So let's paste these in. Okay, good. And we don't need this anymore. So we're gonna get the HTTP library, our schema models, our utilities library, our database library, and our MQTT library. Perfect. Let's go save everything. And connect to our device. Let's see, I've actually already connected to the device here. So let's upload this current directory. This will take just a moment because it's going to be uploading. First of all, it's going to be fetching each of these dependencies. You don't really see this happening down in the console down below, but it's fetching all of our dependencies and installing them on the gateway. You can see it just finished fetching the HTTP dependency, and now it is uploading our current project. So let's run the program and see what happens. Okay, you see that the rules that we have been retrieved, temperature greater than 27, and we're starting to get the data that is being generated come through. We see that for values that are between 20 and 27, the trigger all as well is printed. For values that are less than 20, we get the temperature is too cold trigger. And so our triggers are working correctly. They're being retrieved from the database and run at the proper times. All right, let's go on and build a slightly more complicated
one of our
now.
triggers so that we're using both HTTP and MQTT requests. Let's choose this one here. So the predicate condition here is if the sensor value is greater than 27. And in the case here, we're just logging something to the console. But let's make this a little more interesting. Let's, first of all, get this spacing correct. And then we can paste into here something which makes use of the MQTT client and the HTTP client. Now this should be self here, and logger.error should be changed over to console.log. Console.log. Okay, what this code is doing is if the sensor value is over 27, then we're going to publish an alert to the sensor's temperature alerts topic. This is different than the sensor temperature data topic, which is where this value is coming from. We've created another topic here called alerts. We can also send off a HTTP request to another device that's on our local network, which we're just calling fan and sound. This could be this could just be a fan. And the fan action we are setting to on. So this will send off an HTTP request and be sure to log the success or failure of that request. Keep in mind that anything that is in the self, the .self function, is there because in JavaScript, if we go to our main function here and we pass into this a context function, this context gets put into the self object when the function is being evaluated. So we see that the context is up here. We've included HTTP and MQTT client, and that's exactly what we're using in this area here. I wanted to also quickly show you this eval condition function, which is part of the trigger, and eval trigger function. This might be better named run action or do the trigger, something to that effect. This is the predicate function that determines whether the rule should be run, and this is the actual action that the rule will do once it is run. So let's really quickly go over to the gateway. And you can see I'm here on my gateway. The automation server that we just uploaded is uploaded into this directory called node app slot. And you can see here is our automation service that we just put together. But if we go down into the modules, one of them is called Intel Commercial Edge Network Database Models. And this contains the triggers. I can just show them to you. The schemas for our actuators, for cloud providers, for our data, for different errors, and of course our triggers. So here is the trigger schema. And we'll look up here. So we have a mongoose trigger, and I'm not going to go over how mongoose schemas are defined, but here's the definition of it. But I did want to show you this evaluate condition and eval trigger function, just to show that basically what we're doing here is we are getting the condition function, in this case, which is defined right here, this function, and calling the JavaScript eval on it, which returns a result, either true or false in the case of a predicate function. And then down here as well, we're doing the exact same process here, except for we're calling the trigger function here, which is this function here. Notice that both of these have to be in JavaScript closures. That's just one of the peculiarities of how JavaScript is passed into the eval function. And the result of that is returned. Even though in the case of the action function, what we're more interested in is not necessarily the result of the action, although we might be interested in that, but we're more interested in these side effects, such as publishing to MQTT brokers or making RESTful HTTP requests. So that's a really simple way to set up an automation server that you could run and just to demonstrate the principles of basic automation on an IoT network.